Okay, guys, so now we're starting our chapter 15, which is on random variables. So the first thing that we have to start with is understanding what a random variable is, okay? So the first thing I'm going to say is what it is. So a random variable it's a numerical outcome of some chance process, okay? Which means that some chance process would have already have happened, okay? So I have to kind of set the stage a little bit with an example, okay? So let's suppose that we are tossing a fair coin 3 times, okay? Okay, so I know this now, right? That's easy. If I ask you to list the sample space of this, right, I can flip 3 heads. I can flip 2 heads first and then a tails, or heads, tails, heads, or um, uh, tails, heads, heads. Okay, or I can flip a tails, heads, or tails, heads, tails, or tails, heads, tails, or tails, or heads, tails, tails, and then I have finally my 3 tails, right? So I have 8 equally likely outcomes here, okay? And now I also know that the probability of each of these outcomes would be 1/8, right? So if I ask you for what is the probability that you will flip a tails on the first, a tails on the second, and then a heads on the first, I know it's 1/8, right? Or a tails on the first, and a heads on the second, and a tails on the third would again be 1/8. So each one of these is equal likelihood of happening with a 1/8 chance or a probability for each of these possible outcomes. Okay. Now, where does a random variable come in? So a random variable comes in afterwards. Okay. So now a random variable can be used to describe some numerical value of this chance process. Okay. So if I wanted to focus in on heads, right? So a random variable can be representing the number of heads that come out in this chance process of flipping the coin 3 times. So we always use capitals to represent our random variables. So we're going to say let capital X equal number of heads tossed. Okay, so there was 3 coin tosses, okay? So the maximum amount that you could have tossed is 3, where the minimum would have been 0, right? So x could equal 0, or x could equal 1, or x could equal 2, or x could equal 3. Meaning I could have had 0 heads that would have happened in that last one I had in my sample space. I could have had 3 times where I had 1 heads, right? So that was heads, tails, tails, or tails, heads, tails, or tails, tails, heads. Okay, 2 times that there were heads would have been another 3, right? So that would have been tails, heads, 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 tails, heads, or heads, heads, tails. And then finally, 3 heads would have only happened 1 time if you had the 3 heads. Okay, so these numerical values happen after you are talking about your probability model. Okay, after some chance process has happened, you now have numerical values that can be discussed from these chance processes, and that is a random variable. We don't typically talk about them when we talk about standard probability problems like this. It usually has to do more with like experimental probabilities and historical probabilities. So we'll do something like that in class before we start our discussion on this, okay? So a probability model describes the possible outcomes of a chance process and the likelihood that these outcomes will occur. A numerical value that describes the outcomes of a chance process is called a random variable. So the probability model for a random variable would also be a probability distribution. So you can have probability of random variables, okay? So if we consider the chart that I put up before, right? If X is going to be the number of heads obtained after tossing a coin 3 times, given that sample space, I now know that breakdown would be like what I put up before, okay? Now, the value has a probability. So the probability that the number of heads obtained would be 0 would be 1/8, where the probability that the number of heads obtained would be 1 would be 3/8, and so on. Okay. If I wanted to show this in a histogram, you would notice that this has a symmetrical shape. This is going to play a more important role when we get into continuous random variables in a few videos. Okay, and so now I can now find certain probabilities, right? So of our random variables, right? So if I asked you something like, what is the probability that we get at least one head in 3 tosses of a coin, okay? Notice I'm not asking you something like, what is the probability that you have one head on tails and a tails? I'm asking you, what is the probability that you'll get at least one head in 3 coin tosses? So X being a random variable representing the number of heads obtained, okay? Rather than asking you how many times does this one outcome occur. That's what probability is, okay? So now I'm asking you for the probability of a random variable. Hang on, let me just get this up. Okay, so same situation. Now I'm going to ask you for at least one heads, right? So I'm looking for X number of heads obtained to be greater than or equal to 1, right? So that would happen if I had 1 heads, or 2 heads, or 3 heads, okay? The probability of 1 head was 3/8, and 2 was 3/8, and 3 was 1/8. So the probability of this happening would be 7/8. Now it works a lot the same as your basic probability, which is I could have done the complement. So the complement being 1 minus the probability that X is less than 1. So in other words, 1 minus the probability that X is 0, which is 1/8, which is 7/8. Okay. So I'm actually going to end video 1 here so that we can kind of separate main ideas.